Okay, this is lesson 1B. We're finished with the Module A tests. We're in Module B. First part of this module is working with fractions. So today, we're going to learn about operations with fractions and how we compare and order fractions and simplify some complex fractions. So let us begin. So it helps us visualize fractions so that we can begin to understand our process for adding, subtracting, multiplying, dividing fractions. We're going to start with some picture problems like this. So we have an array of stars here and 3 questions. How many stars are in 2/3 of the set? Well, you could count them all and then take 2/3 of that number, or to visualize that, you could just divide the set into threes. See, now we have the set divided into thirds, and 2/3 of the set would be that many. So however many that is, and that looks like 12. The whole set is, let's see, there's 3 rows of 6, that's 18 total. So there's 6 here, and 6 here. 2/3 of the set would be 12. So we're not actually doing the math right now. We're just visualizing what that would look like. All right, let's try the next one. So how many stars are in 5/6 of the set? Okay, now let's divide up the set in a different way so that we have it divided into sixths. One way you could do that is divide it like this. 1, 2, 3, 4, 5, and 6. There's 6 columns, so 5/6 of that would be this much. So that would be 5 columns with 3, that would be 15. So we're not actually, like I said, doing the operations with the fractions, we're just visualizing. All right, let's try the next one. How many stars are in 7/9 of the set? Okay, this is going to be a little bit more challenging. So we need to divide this into 9 parts. Let's see, if we go back and divide it by threes this way, so now we have those in thirds, and we divide each of those into threes. Let's count those up. I think we have 9 sets that are this big. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 of those. 7/9 of those would be, well, let's see, all but 2, right? So it would be that many. So we have 7 times 2, that would be 14. So once we figure out how many are in each ninth, then we can multiply by 7. Very interesting. Okay, so that's our process of visualizing. Let's see if we can do that with this. What fraction of the square is shaded? Well, one thing that you could do to find out what fraction of the square is shaded, you could visualize, let's say, this shaded area here, and what would happen if we divided the whole thing into shapes like that. And if we draw this, then you might be able to see that we have 1, 2, 3, 4 of those shapes exactly that size. So this shape right here is 1/4, okay? And if we did something like that for the other shaded shape, then you might be able to see that this is also 1/4, because if we just completed that drawing, we'd have 4 of those, right? So 4 of those, so this would also be 1/4. So one thing you could do is 1/4 plus 1/4. So that would be 1/2. 1/2 is shaded. I didn't know if you could tell right at the beginning when we started that 1/2 of this was shaded, but it is. Well, what's another way that we could have done that? Well, let's take a look. What if we divided these 2 shaded shapes into their respective parts like this? Okay, so I'm going to continue these lines across like this, but I'm also going to continue these lines. See, I have one here, and I'm going to continue this one, and I already have one here. Okay, so now how many equal parts do I have? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 equal parts. How many of those are shaded? 1, 2, 3, 4. 4 out of 8 are shaded, so that would be 1/2. So there's just another way to do it. So there's more than one way to visualize some of these fraction problems. All right. So now when we start visualizing things like this to compare fractions, which fraction is larger, 1/5 or 1/4, you might know off the top of your head which is larger. But if you don't, then maybe you could give yourself, let's say, a more obvious example of the same type of thing. So notice that the numerators are the same. They're both 1. The denominators are different. The 5 is larger than the 4. What if we made a more absurd example and made a really large denominator? Instead of 1/5, we said, okay, well, what about 1/10? So, and you might hopefully kind of visualize 1/10. Well, that's a pretty small slice. And then make this one larger, well, I guess a smaller number than that one. So like 1/2. Compare those. Well, 1/10 is smaller than 1/2. Like think about eating 1/10 of a pizza or 1/8 of a pizza. That's much smaller slice than 1/2 a pizza. So that means that the 1/2 would be larger. Okay. So in this case, the 1/4 is larger. Not because we did anything special to like mathematically compare them. We're just visualizing. Like, what does it look like if we cut a pizza into slices that big? Okay? Now, if you want to compare mathematically, then we would have to divide them up into the same type of slices. So we'd have to take, like let's say our 1/2 of a pizza, if this was 1/8 instead of 1/10, I'll make it easier for myself. Then I would want to compare, okay, I'm going to compare 1/2 to 1/8, but I'm going to compare the 1/2 to 1/8 using eighths. So there's my 1/2. Now I'm going to take this 1/2 pizza, or this whole pizza, and divide it into eighths, like this. So now I compared this 1, 2, 3, 4, so I have 4/8 compared to 1/8. Oh, well, yeah, 4/8 is larger because now I'm comparing using a common denominator. When you compare using a common denominator, then you are dividing them into the same sized pieces so that you can compare. So if we compare with a common denominator, then that's kind of like our least common multiple problems. Our denominators are 5 and 4. What's the least common multiple of 5 and 4? So that'd be 20. So we have 1/5 is how many over 20? And 1/4 is how many out of 20? So we need equivalent fractions. And equivalent fractions you can get by multiplying the numerator and denominator by the same amount. Did you notice that in the 1/2, when we changed it into 4/8, we didn't just take the denominator times 4, we also had to take the numerator times 4. So 1/2 is 1 times 4 over 2 times 4, which is 8. So we have to multiply both the numerator and denominator by the same number to get an equivalent fraction. So if you multiply this by 4, that would be 4/20, and if you multiply this one by 5, that would be 5/20, and 5/20 is larger than 4/20. So we had the idea of equivalent fractions, comparing with a common denominator. The least common multiple comes into play, which we learned about. That's so nice that happened. Now, what about these mixed numbers and improper fractions that we have on the second one? Okay. So which is larger, 2 and 1/3 or 13 over 6? Well, there's two different ways we could go with this. Do you want to change this one into an improper fraction? Or do you want to change this one into a mixed number? Do you remember the process for changing this into an improper fraction? 2 and 1/3 is 2 plus 1/3. 2 is 2 over 1. And you might remember when we add and subtract fractions, you need a common denominator. So I'm going to change this denominator into 3. Remember, I have to multiply both the numerator and denominator by 3. So this is 6 over 3 plus 1 over 3, which is 7 over 3. Now, the shortcut, which a lot of you remember, is multiply 3 times 2 plus 1. 3 times 2 is 6 plus 1. That's 7/3. There it is, 7/3. And the reason we're multiplying 3 times 2 is right here. And the reason we're adding 1 is right here. So that's the shortcut. So that's 7/3. We're comparing that to 13 over 6, but we still would like to compare equal size sections, so a common denominator would be nice. Let's multiply this one by 2. So that would be 14 over 6 compared to 13 over 6. And 14 is larger, so that means 2 1/3 is larger. Now, you could have gone the other way. You could have changed 13/6 into the improper fraction by dividing. So every fraction is a division problem. This is division. 13 divided by 6 is 13 divided by 6. Normally we use a calculator, but hey. 13 divided by 6 is 2. That's 12. Subtract 1. 1 is 6. So that's 2 and 1/6. Since this 2 is the same as this 2, I really want to compare the 1/3 to the 1/6. And if I want to compare the 1/3 to the 1/6, then I could know that, oh, 1/3 of a pizza is larger than 1/6 of a pizza, so 2 1/3 is larger than 2 1/6. Or I could get a common denominator, and I could multiply this by 2 to get 2/6 compared to 1/6. 2/6 is larger, so 2 1/3 is larger. Okay, well, that was a lot of stuff. I hope you were able to listen to all that, hopefully, and kind of get a feel for how we're comparing these fractions visually. The math, but there are problems where you can visualize like what's going on in the problem so that you could solve the problem more visually. Let's try this one. Joe and his friends ordered 3 pizzas on Saturday night. All right, so they have 3 pizzas. This could be important. Joe ate 1/4 of one of the pizzas and 1/3 of another pizza. He must have been hungry. What fraction of a pizza did Joe eat altogether? Okay, well, if he ate 1/4 of one and 1/3 of another one altogether, then you could add just 1/4 plus 1/3. Remember, to add fractions, you need a common denominator so that we can, it's like comparing equal size slices, okay? So to get a common denominator, we need a least common multiple. Common multiple of 4 and 3 would be 12. So I'm going to turn these both into 12s. So I'm going to multiply this one by 3. So that's going to be 3 12s. And I'm going to multiply this one by 4. I'm really multiplying by 1 in the form of 4 over 4. So that's going to be 4 12s. And that's going to be 7 12s. So altogether, he ate 7 12s. All right, what fraction of the entire order did he eat? Okay, good question. So he ate 7 12ths of a pizza, but that's not 7 12ths of the entire order, because that would be like more than half of the whole order. He didn't eat more than half the whole order. Because if he ate more than half the whole order, then that would have been more than 1.5 pizzas. He didn't eat more than 1.5 pizzas. He only ate 7 12ths of a pizza. So to figure that out, then we need to figure out Since he ate 7/12 of a pizza, how many 12ths are in this whole order? 3 pizzas is the whole order. And that is how many 12ths of a pizza? Well, 3 is 3 over 1. And 3 over 1 is how many over 12? Okay, so this is an equivalent fraction problem. So we're going to multiply this by 12, which means we have to multiply this by 12. Right? 3 times 12 is 36. So that's 36 twelfths is the whole order. Well, Joe ate 7 twelfths. So what fraction of the whole order is 7 twelfths out of 36 twelfths? 7, here, did you hear how we said that? 7 twelfths out of 36 twelfths. Or 7 out of 36. He ate 7 out of the 36. If the pizzas were divided into 12s, and he ate 7 slices, and there would be 36 altogether, that would be 7 out of 36. So that would be 7/36 of the whole order. So you have to be careful when you're talking about fractions. Fraction of what? So are we talking about the fraction of the pizza or the fraction of the order? Because those are different things. 7 twelfths of the pizza is 7/36 of the whole order. But those are different amounts. Okay, let's see if we can tackle this last problem. If all the people at Joe's party ate the same amount as Joe and there remained only 1/12 of a pizza, how many people were at Joe's party? Okay. So this is one where we kind of have to be careful of what we have here. See, 1/12 of a pizza remained, but those people at the party are eating the whole order. So 1/12 of a pizza is what fraction of the order? Okay. Well, let's find out. So in the order, there are 3 pizzas, right? If you divide that into 12ths, that would be 3 pizzas is how many 12ths? And that would be 36 twelfths. Okay, this is 36 twelfths of the order. 1/12 of the pizza is what fraction of the order? So 1/12 is what fraction of the order? Oh no, it looks like a math problem. And the whole order is 36 twelfths. So 1/12 is what fraction times 36 twelfths? Well, instead of doing that math problem, let's visualize. I like visualizing. Let's just take a look at this simpler example. So I'm going to make this, instead of 1/12, I'm going to make it 1/2. Okay, so there is half a pizza. If they only ordered 1 pizza, it would be half the order. But if they ordered 2 pizzas, then half of the pizza would be 1/4 of the order. See, 1/2 of the pizza is now 1/4 of the order because there were 2 pizzas. So it's kind of like multiplying the denominator by 2 because there were 2 pizzas to make 1/4. Okay, if there were 3 pizzas, then this 1/2 would be 1 out of 1, 2, 3, 4, 5, 6. That would be 1/6 of the order because there were 3 pizzas. So that 1/2, if you multiplied the denominator by 3, because there were 3 pizzas, would make 1/6 of the order. So here's what I just learned. 1/12 of a pizza if there's 3 pizzas, would be 1 out of 12 times 3, or 1/36 of the order. So sometimes it's easier to visualize this way instead of doing this math. Sometimes the math can seem a little overwhelming. Visualize like what you have so you can like try to work it out logically, and that would help. So let's use this information to figure out the answer to this problem. So 1/12 of the pizza was left. That's 1/36 of the order was left. Okay. There was 36. The whole order. Oh yeah, this is important. Whole order is 36. That's the whole order of the order. That's the whole order. 1/36 was left. That means they ate 35 out of 36. 36 of the order. And if you remember from earlier, Joe ate 7/36 of the order. So how many people would there have to be to have eaten 35/36? That means how many 7s go into 35? So that's 35 divided by 7. So that would be 5 people. So 5 people eating 7/36 each would make 35/36 of the order. Hey, here's something that you might notice. If we had 7/36 is the amount that Joe ate, he's one person, and we multiplied that by 5 because there's 5 people, you realize that we're only multiplying the 7 times 5, not also the 36 times 5. That's 35/36 of the order. Okay, well, there's a lot of fraction visualization and fraction work in that problem right there, so hopefully you took the time to take a look and listen. All right, let's try this one. Actually, I want to skip this one for now. It's pretty easy. You can pause it now and solve that problem if you want to. I think the final answer is about 2 cups. I'm going to skip that one for now. Let's try this one. Because we're working with multiplying, dividing fractions and mixed numbers. So here we have a shaded part of a rectangle. If you look at this whole thing as one big rectangle, we divided that big rectangle into 4 parts, and we shaded 3/4 of it. But let's say that we only need 1/2 of that amount. Then what fraction is that? What fraction of the whole rectangle is that? Well, we could just take this whole thing and divide it into 2 parts, right? And cut it in half. So if we cut it in half, now we could just count them up. 1, 2, 3. So if we only need half that amount, we only need 3 of those sections. So that would be 3. But how many sections are there now? 1, 2, 3, 4, 5, 6, 7, 8. That would be 3/8. So that means half of 3/4 is 3/8. So we're actually multiplying when you take half of anything, or this also works with percents and decimals. Of means that we're multiplying, so half of 3/4 would be 1/2 times 3/4. Notice our top number is still 3 because we multiply 1 times 3. And the denominator, 2 times 4, is 8. So we're multiplying straight across. So if we had, let's say, a over b multiplied by another fraction, c over d, that would be a times c over b times d. Multiply straight across. Okay. Nice. Let's try this one. So Heather has 6 pints of ice cream. She wants to divide it into servings. How many 3-pint servings could she make? Well, if you divide this into 3 pints, see there's 3 pints, there's 3 pints. That's 2 3-pint servings. Now, let's do the rest of these and we'll talk about the math that goes with that. All right. How many 2-pint servings? Well, let's see. Where's my eraser? So I'm going to divide this into 2-pint servings. So I'm going to divide it here and divide it here. So there's a 2-pint serving, 2-pint serving, 2-pint serving. That would be 3 2-pint servings. Okay. How many 1-pint servings? Well, if she has 6 pints, there would be 6 1 pint servings? How many X pint servings? Okay, so now let's go back and figure out how we did the math before. So to get this 2, and how many 3 pint servings? To get the 2, did you notice that we had 6 altogether, and we could just take 6, and we're dividing that into 3 pint servings. Divided by 3 is 2. Okay. For the second one, we started with 6 1 pint servings, and then we're dividing that into 2 pint servings. So 6 divided by 2 is 3. For the 1 pint servings, we had 6 divided by 1, which is 6 1 pint servings. So for the X pint servings, what do you think? 6 divided by X. Does that make sense? Because we're like using a pattern here. We divided by 3, then we divided by 2, then we divided by 1. Now we're divided by X. So 6 divided by X. That's how many X pint servings she could make. Now keep that in mind, because we're learning something here. So 6 divided by X. I'm going to write that on the next slide. 6 divided by X. Like that. All right, now how many 1/2 pint servings? Well, if we follow this pattern, we would do 6 divided by 1/2. Now, 6 divided by 1/2, it looks kind of funny because we have a 3-story fraction, which is like never really allowed. We have to simplify that. But let's take our picture and divide it into 1/2 pint servings. So now we have a 1/2 pint servings. How many 1/2 pint servings do we have? If you count them up, there should be 12. So 6 divided by 1/2 is the same answer as 6 times 2. 6 divided by 1/2 is the same answer as 6 times 2. 6 divided by 1/2 is 12. 6 times 2 is 12. All right, let's go to the 1/3 pint servings. So what do you think is going to happen? Well, if we follow the pattern for 6 divided by X, it should be 6 divided by 1/3. 6 divided by 1/3 should be the same as 6 times 3. And 6 times 3 is 18, so there should be 18. So if I go back here and I divide these into thirds, there should be 18 thirds. So dividing this into thirds, you see I'm taking 6 of these pints and multiplying each one by 3 because the servings are 1/3 as big. Okay, get the idea? Yeah. All right, so if there's 1/4 pint servings, that would be 6 divided by 1/4, which is 6 times 4, that's 24. 6 divided by 1/4 is 24. All right, challenging. Okay, how about 3/4 pint servings? Okay, we'll follow the pattern. 6 divided by 3/4. Okay, 6 divided by 3/4 should be the same as 6 times what? So now we need to multiply by 4 thirds. Now 6 times 4 thirds is 6 times 4 over 3, so that's 24 thirds. So that's 8. Now let's use our picture and see if we can visualize that. That's going to be a little harder. Okay, but I think we can do it. So we're dividing these into 3/4 pint servings. Well, I'm going to divide them into fourths first. See, 4 parts. I could do it like this. Okay, so we divided it into fourths. Now each person gets 3/4. So this person gets 3/4, 3 of those. The next person gets 3/4, 1, 2, 3 of those. The next person gets 3/4. 1, 2, 3 of those. The next person gets 3/4. 1, 2, 3 of those. All right, now we're halfway done. Let's stop there and see what we have. There's 1 3/4 pint serving. There's 2. There's 3. There's 4 3/4 pint servings. So if I continue doing that, there should be 4 more, and that would be 8 altogether. So this is correct. 6 divided by 3/4 is the same as 6 times 4/3. Dividing by a fraction is multiplying by the reciprocal. To divide by a fraction multiply by its reciprocal.
Captain, incoming message.
Okay, notice the 6. We did not do the reciprocal for the 6. The 6 remained 6 every time. We didn't flip over the 6. 6 is the same as 6 over 1. And we had 6 over 1 divided by 3 over 4. When that turned into still 6 over 1, staying, times 4 over 3. And 6 times 4 is 24. 1 times 3 is 3. 24 divided by 3 is 8. To divide by a fraction, multiply by its reciprocal. So now we can just practice multiplying and dividing fractions. Here's what I would recommend. Pause, do the math, check your answers after you're finished. Okay, now some of these we're going to take some shortcuts on, but some of these we'll just like go ahead and multiply. So you're paused and doing the math. All right, so you're unpaused now. You're multiplying 3 times 1 and 4 times 2, 3/8. So easy. Now, everything has to be reduced. Final answers need to be reduced. So, a couple things. You could do 2 times 5 and get 10, and 3 times 6 and get 18, but you'll notice 10 and 18 are both even numbers. There is a common factor of 2. So if you reduce that by 2, then that would be divide by 2. Oh yeah, divide the top and the bottom by the same number to reduce fractions. We're taking out that greatest common factor, 5 over 9. Now, quick way, 2 over 3 times 5 over 6. With multiplying, you can do this with multiplying, nothing else. You can reduce any top number with any bottom number. You can treat that like one fraction, because 2 times 5 over 3 times 6 is like 2 times 5 over 6 times 3. The 2 could be over the 6. You could reduce the 2 and the 6 because they have a common factor of 2. You could divide that by 2 and divide this by 2. You divide this by 2, it's 1. Divide this by 2, it's 3. Now you could just multiply straight across. 1 times 5 to get 5, and 3 times 3 to get 9, 5 over 9. So you could reduce first. So nice. All right. 2.5 times 4/5. 2.5. You have to change that into the improper fraction. 2 times 2 is 4 plus 1 is 5. That's 5 halves times 4/5. And we're going to go ahead and reduce, because look, we have a 5 here and a 5 here. Those totally reduce out to 1s. And 2 goes into 4. 2 goes into 2 once. 2 goes into 4 twice. The whole thing should be 2. If you multiply straight across, then it would be 20 over 10, which is 2. Okay, when you multiply by a whole number, 3/8 times 2, this 2 is like 2 over 1. And you could reduce the 2 and the 8. 2 goes into this once and into this 4 times. So that's 3 times 1 over 4 times 1. If you have a multiple fraction multiplication problem like this one, then try to reduce things out first. These 3's reduce out totally because they both turn into 1s. 3 over 3 is 1 over 1. 2 goes into there once, and 2 goes into there 4 times. And now the numerator is just 1 times 1 times 7, which is 7, over 1 times 5 times 4, which is 20. It's already reduced. Okay, now dividing fractions. Remember, dividing fractions is multiplying by the reciprocal. So we're going to multiply by 3 over 2. But the 5 over 9 stays the same. Now that it's multiplication, you can reduce the 3 and the 9. 3 goes into there once and into there 3 times. So it's 5 times 1, which is 5 over 3 times 2 is 6. And then the last one, this 2 is 2 over 1, but we're dividing, so it's 2 over 1, which stays the same, times 5 over 4. Then you could reduce the 2 and the 4 to get 5 over 2. So how'd you do? All right, let's try these. Adding and subtracting fractions. When you add and subtract fractions, you need a common denominator. Not in multiplying and dividing. Adding and subtracting fractions, you need a common denominator. That's like adding equal size slices of the pizza. 1/8 plus 2/8 is 3/8. If you ate 1/8 of the pizza plus 2/8 of the pizza, that's 3/8 of the pizza, not 3/16. Don't add the eighths. We're combining like terms, basically. When you have two denominators that are not the same, you need the least common multiple, least common denominator. So let's use 24. So we have to multiply this by something to make it 24. 4. So 4 over 24. And multiply this by something to make it 24. Let's use 3. So 9 over 24. 4 plus 9 is 13 over 24. Sometimes the least common denominator is what you get when you just multiply them together. 5 and 8 have no common factors, so we can just multiply 8 on that one and 5 on this one. So this is going to be 8 over 40 plus 15 over 40. 8 plus 15 is 23 over 40. Oh, what about when we have a denominator that is a variable? It's okay, as long as it's a common denominator. And we have a common denominator. So 1 over x plus 2 over x would be 3 over x. It's exactly the same as a. 1 over 8 plus 2 over 8 is 3 over 8. 1 over x plus 2 over x is 3 over x. Okay. If we don't have a common denominator and we have variables, then we need to make a common denominator. How do we make a common denominator? Multiply the numerator and denominator by something to get the least common multiple. What if we multiply this one by 2? So we have 1 over 2x plus 4 over 2x. Now we can add 1 plus 4. That's 5 over 2x. Nice. Okay, what if the denominators have nothing in common? Well, then we can multiply them together just like we did on problem C. So if we do that and we multiply this one by b and this one by b, just like up here we multiplied by 8 and 8. If we multiply this one by a and this one by a, just like up here where we multiplied that one by 5 and that one by 5, then we'll have 1b over ab plus 2a over ab. BA and AB are the same. Multiplication is commutative. Now we can add those together, but the numerators are not like terms, so we have to leave them separate, but we can write the additions problem. 1b plus 2a over ab. Now you might see this problem also written like this. 2a plus b, 2a plus b over ab. So 2a plus b is the same as 1b plus 2a. 1b is the same as b. Addition is commutative, so we can change the order. So this is okay. Either way is fine, but I usually like this. Alphabetic order is nice. All right. Let's try these. These are complex fractions. Remember I said before that we don't really want to have a three-story fraction. Three-story fractions are kind of a no-no. And over here we have some four-story fractions. That's even worse. So you notice that this heavy fraction bar there, that one. That's our division problem. So we're going to write this as a division problem. Then we can solve it. Don't try to just plug this into your calculator because the calculator will not understand if you just type in 2 over 3 over 3. Your calculator will not calculate that correctly. You have to tell the calculator exactly what you're doing because they don't understand three-story fractions either. So this is 2/3 divided by 3. Okay, now we're going to make this 3, because we're dividing a fraction, into a fraction. So now when we're dividing by a fraction, you have to remember to multiply by the reciprocal. So now it's 2/3 times 1/3. Remember, the first fraction did not change. We're multiplying by the reciprocal of the fraction that we were dividing by. And then we could just multiply straight across. 2 times 1 is 2. 3 times 3 is 9. 2/9. When you have a division problem between two fractions, it looks like a 4-story fraction. That's a division sign. Write it as a division problem. 4/5 divided by 8/15. Then use your process for dividing fractions is to multiply by the reciprocal. Turn it into multiply by the reciprocal. Times 15 over 8. Seriously, it's easier that way. Keep the first fraction the same. Reduce this one. 5 goes into there once. 5 goes into there 3 times. 4 goes into there once. 4 goes into there twice. 1 times 3 is 3. 1 times 2 is 2. It's 3 over 2. It's okay to leave your answer as an improper fraction as long as it's reduced. All right, now we have variables. Let's do the same thing. So now we have x over 5 divided by y over 3. So this x over 5 stays the same, multiplied by the reciprocal, 3 over y. Nothing reduces, we just multiply straight across. X times 3 is 3x. 5 times y is 5y. 3x over 5y. And then the last one, we're going to change this mixed number into an improper fraction. So if you want to use that little shortcut rule, 4 times 6 is 24 plus 3, disregard the negative sign, and we're going to throw the negative sign on the end. So this is the negative of 6 3/4. Just do 6 3/4. 4 times 6 is 24. That's 27 fourths. Then put the negative sign back on it. Okay? Because otherwise, then you can't make part of the mixed number negative and the other part positive. You can't do that. If it's negative 6 3/4, it's negative 6 and negative 3/4. Okay, so now we have 3/8 divided by negative 27 fourths. So now I can multiply by the reciprocal. 3/8 times negative 4/27. And now in this one I can reduce because 3 goes into there once and it's good. 3 goes in there 9 times. We can reduce the 4 and the 8, but don't just lose your negative sign. 4 goes into there once. 4 goes into there twice. So we have a negative sign. So it's negative because a negative divided into a positive would be negative. And we have on the top 1 times 1, which is 1. 2 times 9 is 18. 1/18. Okay, check to see how you did. And let's go on. Now these complex fractions have math problems in the numerator or the denominator or both. So in that case, you have to do the math and then do the math again. Okay, well, some of them are not that hard. Like on A, 19 minus 4 is 15. This is just 15 over 6. That's not reduced. We have to reduce now. Reduce the 15 and 6 with a common factor of 3. So that's going to be 5 over 2. 24 minus 15 in the denominator. See, the 48 is going to stay the same for now. 24 minus 15, I believe, is 9. And then reduce that one. Those are both divisible by 3, I believe. So that would be 16 over 3. Perfectly okay to leave an improper fraction answer. Now on C, we have 2 math problems and then a third math problem. First math problem is the numerator. So I'm going to go down here and I'm going to add 4/5 plus 3/4. I need a common denominator, so I'm going to multiply this by 4 over 4 and this by 5 over 5. So that's going to be 16 over 20 plus 15 over 20. So that's 31 over 20. So my numerator is 31 over 20. Okay, now I have to do a second math problem in the denominator. So that math problem is going to be, let's see, 4/5 minus 1/2. With the common denominator, I'm going to multiply that one by 2's, this one by 5's. So it's going to be 8 over 10 minus 5 over 10. That's going to be 3 over 10 over 3 over 10. Okay, now I have a complex fraction that I can divide. So I have 31 over 20 divided by 3 over 10, which means I'm going to have 31 over 20 times 10 over 3. And then I'm going to reduce the 10 and the 20 and multiply straight across. 31 over 6. Okay, well that was a lot of stuff. So if you have a complex fraction, which means a fraction problem over another fraction problem, then you have 3 problems to do. You have the math problem in the numerator, the math problem in the denominator, and then the math problem of the numerator over the denominator. All right, let's try problem D. In the numerator, we have 3 squared plus 4 squared. All right, well, let's do the math. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. Over negative 135 over 9. So I'm going to write this as a division problem. 25 divided by negative 135 over 9, which is now 25 times the reciprocal, still negative, 9 over 135. Now I could multiply 25 times 9. This 25 is over 1. But I'm pretty sure I can reduce the 25 and the 135. The reason I know that is because 25 and 135 both end in a 5, so they're divisible by 5. So I'm going to divide this by 5. 25 divided by 5 is 5. And I'm going to divide this by 5. Let's see, 5 into 135. Should go in there 27. Aha, I just noticed something now. Here's what I have. So far, I'm not going to multiply yet. I have 5 over 1 times negative 9 over 27. I did not notice this before, but this negative 9 over 27 is reducible. I could multiply across now, but then it won't be reduced. I'm going to reduce this first. So 5 over 1 times, I'm going to divide both those by 9. Negative 1 over 3, because 27 divided by 9 is 3. And that's going to be negative 5/3. Nice. So there's lots of things you can do to help the math go along a little quicker. And when multiplying, not when dividing, when multiplying, just like this one and that one, you can reduce first so that you don't have to reduce so much later. Okay, more. Now these are a little bit more complex. So on these, same thing. We have a math problem in the numerator. Then we have a math problem in the denominator. Then we have the numerator over the denominator. So the first math problem we have to do is 1 minus 3/4. Well, 1 is 4/4. So 4/4 minus 3/4 is 1/4. So that's 1/4 over the denominator. All right. Now, when I do 1/8 plus 2, I'm not going to write 2 and 1/8. Okay? If you do write 2 and 1/8, then use what you know to make that into an improper fraction. 2 times 8, 16, plus 1, 17, 17/8. Or you could make this 2 into 2 over 1, get a common denominator, multiply by 8 over 8. So that's 16 over 8 plus 1 over 8 is 17 over 8. 17 over 8. Okay, then turn that division into multiplying by the reciprocal. 1/4 divided by 17 over 8 is the same as 1/4 times 8 over 17. And then reduce, if possible, after its multiplication. Not in the division phase. After its multiplication, 4 goes into 8 2 times 2/17. Yay, okay, all the rest of these problems have just variables. Okay, so, same thing. Now this numerator here, there is nothing we can do with that. It's a single fraction. It's a plus b over 2. We're just going to leave it a plus b over 2. Now, see, this is two fractions. These I need to combine together. If it's a single fraction, that's good. I can use a single fraction in multiplication and division. But I can't use two fractions in multiplication and division. So in the denominator, we have 1 over a plus 1 over b. It's addition, so we need a common denominator. So we're going to multiply this one by b on the top and the bottom. Don't forget it's the top. And multiply this one by a. So now this becomes b over ab. This one becomes a over ab. So when we add them together, a plus b, because I like alphabetic order, over ab. See, now it's a single fraction. So that's my denominator. So here's what I have now. I changed, let's go back to this. A plus b over 2 divided by a plus b over ab. Okay? All right. Now I know some of you are tempted to do two things at once, such as immediately write that as multiplying by the reciprocal. But I just want to keep things simple. So now I have a plus b over 2 times the reciprocal, ab over a plus b. Okay, reduce. And you might be looking at that going, reduce? Yes. See, this whole numerator is a plus b. This whole denominator is a plus b. They are the same. It's like canceling out a 5 and a 5, or a 3 and a 3. Canceling out the a plus b with the a plus b. And remember, when you cancel those out, they turn into 1s. So it's 1 times ab, which is ab. And 2 times 1, which is 2. Our final answer on that one is ab over 2. Okay. All right, let's try C. This would be a good one now that you have some experience. You try it. And D, pause, try it, unpause, check your answer. Okay? Numerator 1 plus 5, or 1 over 5, sorry, plus 1 over x. Common denominator, multiply by x, multiply by 5. So now I have x over 5x plus 5 over 5x, which is x plus 5 over 5x. So that's my numerator. Okay. X plus 5 over 5x. All right. See, I'm trying to keep things straight. Don't write stuff all over the place and then forget where it goes. All right, the denominator. Look, this is already a single fraction. See, it has a single denominator. It's already a single fraction. So I don't have to do anything with that except now write that into my problem and divide. Okay, so that division problem is x plus 5 over 5x divided by, I know I'm writing as division first, x plus 5 over 2. That way I can keep it upright. All right, so then I'm going to turn that into multiplied by the reciprocal. Still x plus 5 over 5x times 2 over x plus 5. What happens? The x plus 5's cancel each other out. Final answer? 2 over 5x. Nice. Okay. So I hope it's going well. This is the last problem to do. This is kind of a fun one. In our numerator, we have a math problem to do. See, that's two separate fractions. Yes, that 1 is a fraction. So that's 1 over 1 minus 1 over x. Okay. Common denominator because we're subtracting fractions. So we'll multiply this by x. Now, you could multiply this one by 1, but what does that change? Oh, yeah, nothing, because 1 is the identity for multiplication. So now we have x over x. Leave it x over x. Don't say, oh, but that's 1. No, we knew that it was 1. That's where we came from. Minus 1 over x. See, we had to do that to get a common denominator. So that is now x minus 1 over x. So this numerator here is x minus 1 over x. Okay, so now we need the denominator. The denominator, we have addition. Looks almost the same, but it's addition. So it's 1 over 1 plus 1 over x. So let's multiply this one by x. And when we do, then we're going to have x over x plus 1 over x. Okay, and that's x plus 1 over x. So this becomes x plus 1 over x. Okay, so now our division problem is x minus 1 over x divided by, yes, I'm writing as division first still, x plus 1 over x, which is now going to be the multiplication problem, x minus 1 over x, times the reciprocal, x over x plus 1, and this x in the denominator cancels out with this x in the numerator, leaving us with x minus 1 over x plus 1. Okay, now, see, I'm putting a box around that. That's my final answer. Do not cancel out those x's. Here's why. See, let's just pretend that we know what that x number is. Let's say that it's, I don't know, 4. If x is 4, then this is 4 minus 1 over 4 plus 1. If I cancel out these 4's now, then I get negative 1 over positive 1, which is just negative 1. But, see, this fraction bar here is almost like parentheses. So it really wants you to do the numerator and denominator separately and then divide. So that 4 minus 1 is 3, and that 4 plus 1 is 5, and 3 over 5 is not equal to negative 1. See, you can't cancel those 4's. Same way, you cannot cancel these x's. That's it. It's x minus 1 over x plus 1. Do not cancel those x's.
because it's adding or subtracting. Now, if it was x times -1 and x times 1, yeah, then we could cancel them out. But it's not. It's x minus 1 and x plus 1. Okay? So there we go. Well, I hope that wasn't too long. There was a lot of fraction work here on the last couple of pages with those complex fractions. I hope you got all the way to that. So good luck with that.